So we'll talk about intestinal flukes, or also known as intestinal trematodes. And within our conversation today, the learning objectives will be that by the end of this conversation, you should be able to identify and distinguish different intestinal flukes or intestinal trematodes. You should be able to discuss the pathologies that is caused by the intestinal flukes and what treatments do they get. And also you should be able to mention the control measures for each of those intestinal flukes, right? So as an overview, there are several features that are important and they are happening across all the intestinal flukes, right? So these include that all intestinal flukes are primarily distributed in Southern East Asia and East Asia. They're found everywhere else, but they're primarily distributed in this territory. And also the human-acquired infections by eating raw aquatic plants or uncooked snails or snakes or frogs that contain the metasaccharide of these flukes. And then also most infections are usually asymptomatic, irrespective of the fluke, and they produce mild GI gastrointestinal symptoms, such as diarrhea or abdominal pain, but also heavy infections. When they're heavy, then they become symptomatic, where you can get anemia, malabsorption, and protein-losing enteropathy. These are all features associated with the presence in the intestinal lumen. And then the small bowel obstruction or perforation is rarely reported as a severe complications of the large intestinal flukes, such as Fasciolopsis buski. But this is, obstruction and perforation is very common in other types of worms, as we've seen with the scaries and things like that. And the main therapy for this intestinal flukes is praziquantel. So this slide will summarize everything you need to know about the intestinal flukes, but we'll get into details one-on-one as we go. So again, the intestinal flukes in general, they are found in adults' intestinal tract, and the eggs of these intestinal flukes are found in feces. And the infection in man is usually foodborne. And the infection is spread by contamination of water with human and animal excreta. So you already have an idea right now what will be the important control measure for controlling this intestinal flukes, including having toilets. But parasites are usually hermaphroditic, different from other parasites that we've seen. For example, the schistosomes, they would need to have male and female, but these ones are hermaphroditic, that they can produce eggs and fertilize it themselves, so they don't have different sexes, and the eggs are usually operculated. So there are mainly about 5 intestinal flukes that are known, and most have some similarities with each other. So we could have in the small intestine, we have Fasciolopsis buski. And then we have Iconostoma ilocanum, we have Metagonimus yokogawi, and Heterophyes. These are the ones that are usually found in the small intestines as adults. And within the cecum, or the ascending colon, if you remember your anatomy, you have Gastroscoides hominis. So these are where you would find this particular parasite. And I'm going to discuss each one of these parasites as we go, but you have now an idea of everything related to them. So this is an image showing you relative sizes, shapes, and morphology of these different intestinal flukes. So we could start with number A. This is an Heterophyes. Heterophyes is very closely morphologically related to Metagonimus yokogawi. So A can also be Metagonimus yokogawi. They will be slightly different. I'll tell you about them later. And then B, we have this parasite, which is similar to Echinostoma, parasite B, which is similar to an Echinostoma family. And then C, we have Gastrodiscoides, which is a very weird shape. And we have Fasciolopsis buski, which is there. So this is how their relative size is. So this is how 5 millimeter is to this, and this is how 1 millimeter is to this parasite. Just so to give an idea that Fasciolopsis buski, just from this image looking here, is the biggest of them all. Now, the characteristics of these flukes, as you can see, we have heterophyes that is found in the Middle East and South Europe and Asia. Transmission is through eating raw fish, and this is the relative size, about 1 millimeter by 0.5 millimeter. And then this is an average size, right? So it's not like exactly this is the numbers, these are human beings, these are animals, so they could vary a little bit, but these are average sizes. Metagonymous yokogawa, which is almost the same size as heterophyes, you could see around 1.4 by 0.6, also through raw fish, and found in Japan, Korea, China, and Siberia. Echinostoma, which is usually found in the Philippines, you can find through eating raw fish or snails, and that's slightly bigger in terms of 2.5 to 8 millimeters. We have Gastrodiscoides, which are usually found in India, Vietnam, Bangladesh, and Philippines. Usually found by eating raw water plants like watercress. You'll see these raw water plants in a moment, and these are slightly bigger in terms of 5 by 3 millimeters. And the Fasciolopsis buski, the giant of them all, which is found in raw water plants, and this is a relative size. And as we're going to be discussing this, there's usually an intermediate host from the parasite to the intermediate host, the second intermediate host, where it gets to infect a human being. So the intermediate host is usually snail. So for heterophyes, this is called Pyrenella, and for metagonymous yokogawa, we have Semisculospira, and then Echinostoma, we have Garrulus, and then with Gastrodiscoides is Helicorbis, and Fasciolopsis, we have Segmentina and Hippidias. These are species of snails that would be intermediate before the parasite gets into the second host, which is then going to be entered into the human being life cycle. All right? Right. So it's important to remember these intermediate hosts, because when you're talking about control measures, the old use molluscicides to kill the mollusks, which are these ones, they die. So general life cycle includes adults in the intestines. They make eggs in the feces, and then eggs in the feces develop miracidium in the snail, and then miracidium in the snail develop into secari, and then the secari develops into metasecari. But this metasecari stage is inside the fish, snail, or water plants. Here is in the snail. So the secari get out and then get into the metasecari, and then gets ingested by human beings, and then get in the adult intestine, and then it is now a cycle, continues like that. So that is what I've been describing in terms of where they're found. The miracidium develop in appropriate snails, depending on the type of the species, into the sporocyst, then radi, and then into secari. Secari now gets out, and then it insists in fresh water to form the metasecari, and then the metasecari, once ingested, it exists and becomes a part of the human. This is an image of the video that shows an example of where you could have what is called these water plants, watercress. So you can see how they're processing them from different. This is a water pond, a big pond that has water, and then they like water lilies or things like that. So this is in Asia, and then they take these little plants. Now, imagine this is a more advanced farming where people would have, boots and the gloves in handling this. But there are some people who are farming these products who are much more rudimentary, and they would use their own feet without having to they can get risk of contamination of other things, but also these products, they're eaten raw sometimes, or sometimes they're light boiled. So people would get infection through parasites that can get inside. There's watercress plants, right? So this is an example. They look like little devils, but this is how you get the nut out of it, and the fruits that can be eaten. That's the watercress, right? Great. So the epidemiology, when we're talking about these parasites, the human, dogs, and cats, and other raw fish eating mammals are the reservoirs, and human infection from eating undercooked or pickled or smoked or salted fish can be a cause. And then using human feces as food source, for example, in fish ponds, it perpetuates the infection. So some people would like to recycle the feces and feed them to fish. I don't think you would like eating feces if you were you, but the fish eats, and this is, not good because it perpetuates the infection. And other people use that as fertilizer. So also snails and fish are involved in the life cycle. The diagnosis is usually history or residence in an area that is endemic of this parasites, or consumption of raw foods and symptoms that are suggestive of the disease. Also, if you examine the stool specimen for eggs, by either through direct microscopy or using a ether concentration method, you learn this in the lab processes. But also sometimes you could recover adults, which is rare, but in heavy infection, you might be able to recover adults from stools or from endoscopy. Prevention, make sure you cook all freshwater fish and vegetables and snails. If you eat the snails, cook them well. The night soil, night soil is an equivalent of feces. This should not be used in fish pond without disinfection or storage for a long time until the eggs die. And the sanitary disposal of human feces, meaning you should have toilets. And this is an important thing. And we all have these campaigns, even in Tanzania, nyumba ni choo. So having a toilet is good. Don't poop near lakes. Or people should be health educated to aim to change these habits of either eating raw foods or preparing well these raw foods, and snail control. And now, so what have you spoken to you about is an overall for all the parasites. And now we're going to really quickly go through each parasite and the specific features, and you'll be able to understand. So this is now the giant intestinal fluke, which is a Fasciolopsis buski. It is found in Asia, China, Taiwan, India, Bangladesh, Thailand, and Cambodia. And adults are attached to small intestine by the ventral sucker. So he has a little sucker in the stomach, in the ventral area. This here is the ventral sucker. Hope you can see it. This is where they use to attach themselves. And then it has the largest stromatode, as I said, is thick and ovoid. It does not have a cephalic cone. This is, you will be able to differentiate this with the Fasciola hepatica. I don't know if you see a study about the Fasciola hepatica, which the Fasciola hepatica has shoulders like this, and then has a cephalic cone like this. Right, this one doesn't. So this is one of the differences between this parasite and then Fasciola hepatica. And then this one has testes that are posteriorly located. The testes, you will see them, testicular branches that are posteriorly located. You will see this. And then you would have female sex organs that are branched. So here, these are the branches of the female sex organs. You could see them, you could be able to appreciate the way they're branched like that, right? So this is a morphology of the Fasciolopsis buski adult. These are the eggs. The eggs are usually large in terms of 130 to 140 micrometers. And the yellowish, thick brown shell And they are usually unembryonated when laid. We have already previously discussed the differences between unembryonated and embryonated eggs, and they're almost identical to that of Fasciola hepatica. Okay. And this life cycle, now, an important factor you need to remember in the life cycle, just how we've discussed in the generic life cycle, this one is 3 to 7 weeks to develop in fresh water at temperatures that are usually tropical temperatures. So this is an important factor to think about when you want to think about control, right? When you want to control this, when you use the feces, that they need 3 to 7 weeks, which means you need to store them much longer for the eggs to die before you start to use these feces. And the miracidium would hatch out and enter the freshwater snail. And the segmentina, which is a specific snail species for Fasciolopsis buski. And in the snail, the sporocysts develop, and then 2 radio stages are formed, followed by the cercari. I believe now you remember the radio stages that are formed in these parasites. Then the cercari leaves the snail, gets into water, gets into the roots of freshwater plants, example, the water callop and the water chestnuts, or water chestnut that are the one that you've just seen in the video of, and then they stay there in the roots, and then if you eat them, you get contaminated, right? And then once you eat in the small intestine, it takes at least 3 to 4 months for the young flukes to develop into sexually mature adults. Great. And the pathogenesis, adults is usually a traumatic inflammatory damage to the small intestinal mucosa at the site of attachment. Just how we've seen in other parasites, they would cover the villi and the damage and leads to ulceration, sometimes hemorrhage, and can also provoke excessive mucus secretion, which would naturally lead to diarrhea. But normally the morbidity is mild, or you can have no morbidity with mild infections. But now with a severe infection, since it's large parasite, it can lead to that infection. And then it also depends to the number of worms, and heavy infection can lead to, as I said, diarrhea, abdominal coli, weight loss, generalized weakness, and edema, and in children can lead to poor failure to thrive and poor development. So, and moving on to diagnosis, again, recovery of eggs and feces. The treatment is praziquantel, 25 milligram per kilogram, 3 times a day, or 40 milligrams per kilogram as a single dose, can also be used depending on that. And the other option is niclosamide. Prevention and control, edible water plants should be carefully peeled and washed and boiled for a few seconds, could be to kill the metasaccharide. Don't just eat raw. Night soil should be stored for some time before use so that the eggs could die. Then you should do snail control using molluscicides. Molluscicides is chemicals that kill mollusks, which are snails. Heterophyes, which is similar to Motogonimus, is found in Middle East, Southern Europe, and Asia. Adults usually attach the wall of the small intestine. And the morphology, these small flukes are in size of about 1 to 2.7 millimeters. They are elongate, ovoid shape. The tegument, which is a covering, has very fine spines. You'll see the picture. And there's an oral, ventral, and genital sucker. These are points of sucking. And eggs are usually passing feces. They are usually the same size as Opistrochis and contains fully formed embryo. So these are embryonated eggs. And then the eggs are opaculated with a knob on the opposite end. You will see them here. So you can see they have, the tegument has like rough edges. I don't know, you'll be able to appreciate on the skin here. If you look carefully, you'll see that like very fine spines. And this shape and size is similar to what you'll see in Metagonymous. And the eggs are you can see here they have a cap, which is opaculated, and have a little knob on the side. Okay. And these eggs are ingested by water snails, which is Pyrenella conica of the Nile Delta. And Miracidia undergo asexual multiplication, which into sporocysts, radia, and finally into the secari, and they emerge in water. And the secari penetrates freshwater fish, different from what we've seen in Fasciolopsis buski, which it penetrates the roots of the water chestnuts. This one was the freshwater fish, and then the man is ingested by eating raw undercooked fish. And then these metasecari are released into the small intestines, and then they develop into sexually mature adults. They cause mild mucosal inflammation at the attachment site, and they can even cause superficial necrosis. In light infection has no symptoms, and heavy infections usually cause nausea, diarrhea, and abdominal colic. And these are usually incidental findings when someone has is examined for something else. They can usually find these eggs, and that's how you get fined, but not necessarily when they're symptomatic. Diagnosis: find the eggs and feces, which is your basic microscopy. Treatment: praziquantel and niclosamide. The control: cook your fish, don't poop in the lake or places where fish are found. And then again, molluscides. Metagonymous yokogawi, as I said, this is also found in similar places with heterophyes. And the adults are in the small intestines, are embedded into the mucosa fold or the mucus. And then because they're very small, there's have similar structure and size, except that the metagonymous yokogawi, the ventral sucker is to the right of the midline, right? And there are no accessory genital sucker. So if you look at this picture, the ventral sucker, this one, is to the right of the midline. So usually it's on this side here. They don't have accessory genital sucker. And eggs are similar to those of heterophyes. Life cycle is similar to the one of heterophyes in terms of it gets through fish. And the snail species that are involved, these ones are semisculospiral, which is different, semisculospiral libertina, while the other one were Pyrenellas, and fish is a second intermediate host. Now, another one is Echinostoma ilocanum, which is found in the Philippines, and there is a natural parasite of dogs and rats, and occasionally a man. And in adults, it attached into the small intestinal mucosa using an oral sucker. And the morphology, these are small flukes, as you've seen. These are 2 to 8 millimeters, but then they're visible with naked eye, so it means you find them, but they can, you can, on the microscope, they look much bigger. And have a collar of spines behind the oral sucker. They have a very interesting morphology. You'll see in a picture next year, and the eggs are unembryonated in plastic pieces. So this is how they look like, the echinostomas. They have this really interesting collar of spines in the anterior part, this is like a zoomed version of this part, right? And they of course have the testicles, their uterines, and of course the food ingesting areas. And these are the eggs that are there, and you could see the shape, what they look like. They're unembryonated. And then the life cycle of the unembryonated eggs, when they reach water, they embryonate outside the feces in the water, and they form the Miracidia. Now the Miracidia penetrate the snails. The snails here are Gaeralus. I mean, you should remember the table that I summarized for you to be able to identify these different things. And each snail sporocyst, in the snail, the sporocysts are formed, and then they develop radia, and then the secari, and then as usual, the secari release into the water. They get into edible snails or fish, and then they insist to metasecari, and then the man is infected by ingesting these second intermediate hosts. of metasecari. They're released into the small intestine. This is a small intestines, and develop into sexually mature adults. Pathogenesis, clinical features, control is similar to fasciolopsis. Why is it similar to fasciolopsis? Remember, these ones are they get into the life cycle that is similar to the fasciolopsis. So this is the part where you can control pathogenesis and clinical features. And then one of the other ones is gastrodiscoides hominids, which is common infection in India, but also occurs in Bangladesh, Vietnam, and the Philippines. We're telling you about these diseases because you might end up practicing in these areas where these diseases are prevalent, and you should be able to understand that these are potential findings. And others attach to the wall of the cecum and the ascending colon. As I said, this is the only one which is intestinal fluke that is in the cecum and the ascending colon. And this is how it looks like in terms of the morphology. It has a discoid shape and a projection. And it's also slightly big, and the ventral sulcus are closely to the posterior extremity here. The dorsally convex fluke, the body is this shape with an anterior projection and has a smooth tegument. Tegument is a skin, so the skin is very smooth. And the eggs are unembryonated when in feces. So unembryonated eggs develop in water, and in 9 to 14 days, they get to at 24 degrees temperature for miracidia. The eggs hatch and release the miracidium into the snail. The snail species that takes these ones is Helicorbis, and then the snail develop to form mesecaria that emerge up to from a month to 3 months. This is usually experimental studies that have shown this kind of development. And secaria insist into water plants, it's like a water caltrop, to form metasecari. Eat that one, you get infected. Inflammation of the mucosa is one of the causes of the cecum and the colon. It may lead to surface desquamation with edema and thickening of the submucosa because of their presence. Light infections don't have symptoms, but heavy infection cause diarrhea, and even intussusception might end up occurring in very heavy infections. Diagnosis, treatment, and prevention and control is similar to that of Fasciolopsis buski. Right, so if you have any questions, let us discuss them and keep putting them in the chat. We'll respond. Thank you very much.